Welcome back to these series of lectures. This is History 1122, second half of Western Civ. We're going to talk about the scientific revolution today. I took the notes that I use here for this lecture. I took them from Dunn's book, The Age of Religious Wars, and from Will Durant's The Age of Reason Begins. Context first. I guess you could say the scientific revolution is sort of born of the Renaissance. It lies at the heart of what we think of as the Age of Reason. It leads us directly into the Enlightenment, which we'll talk about. So it's part of this sort of big intellectual boom in late, early modern Europe, 14th, 15th, 16th, 17th centuries. Significances. The scientific revolution represents an epistemological challenge to traditional ways of knowing. Epistemological, epistemene is the Greek, from the Greek meaning knowledge, and of course ology, the suffix, means the study of. So epistemology is the study of how we know. This is generally or traditionally a topic for philosophy class. But I like to bring it into history classes as well as a way to get students to think critically about how they know things instead of simply accepting passively the information that is pouring in constantly. Traditional ways of knowing, Aristotle and Ptolemy with their descriptions of the celestial bodies, the great chain of being, Christianity. These are all going to be challenged now by these scientists that are emerging here in the, again, 16th, 17th centuries. I heard one historian refer to this time period as the Age of Genius. It's hard to argue. This is the time of Shakespeare. Whether you've read Shakespeare or not, he is pervasive in the English language. You probably use phrases from him and are not even aware of it. Of course, Cervantes, El Greco, the great Spanish painter, Descartes, one of the champions of modern mathematics and philosophy. Of course, Galileo, who we'll talk about here in a few moments, in astronomy. Rubens, the great painter. John Milton, the great English poet. Bernini, Google Bernini and look at his sculpture and tell me if that's not genius. Rembrandt, the famous Dutch painter, Velasquez, Hobbes, Spinoza, Newton. Indeed, this is a time of genius. We'll talk about Newton a little bit in our discussion today. And of course, John Locke, who you know about probably from American history, with his attack on the divine right of kings, his notion of natural rights, and so just a remarkable collection of intellectual giants emerging in this time period. So let's talk about this emergence of science between the middle of the 16th century to the 1680s. A brilliant group of astronomers and physicists and mathematicians, including Copernicus, who we'll talk about briefly, Kepler, Galileo, Descartes, Newton. These scientists sort of obliterate the traditional way of knowing the world, again, epistemology, or an epistemological challenge. Science establishes a way of doing things, a scientific method, whereby you can propose a hypothesis and then run experiments to test the validity of that hypothesis. To understand this better, we're going to look just briefly at sort of the pre-Copernican science, the pre-Copernican ideas of how the world works. Nicolaus Copernicus, of course, is with whom we will start, the Polish astronomer in the 16th century who came up with a dramatic paradigm shift in how we understand the universe. The old model, the geocentric model, the Earth-centered model, is going to be discarded, and a heliocentric model will take its place. This is a dramatic shift in how we understand our place and our planet's place in the universe, and it starts with Copernicus. So before we get to that, I want to talk a little bit about the pre-Copernican scientific world to give you something to contrast it with. It was believed that God had created all living things in this immenseful and purposeful and harmoniously ascending order, the great chain of being with God at the top, and then through the heavens down to the earth, and then on the earth, man down to the lower organisms. There's a great chain of being that we seek to replicate in our own governments with the divine right of kings, and the nobility and the church, and then down to the peasantry. The system of feudalism looks very much like this great chain of being applied to society. Pre-Copernican science, well, you have the four humors, you have the four elements. There's a tendency to want to create a balance, a certain symmetry. The four humors, melancholy, phlegm, blood, choler, these are thought to pass through the heart and the liver. In pre-Copernican science, if you could keep the patient's humors in balance, you could preserve his good health and his normal temperament. In pre-Copernican science, we had folklore, fairies and pixies and supernatural beings that meddled in human affairs for both good and ill. In pre-Copernican science, we had witchcraft. We had evil spirits and ghosts. Evil spirits, of course, are fallen angels, and of course we had the Satan himself interfering in humanity. In pre-Copernican science, there wasn't really confidence that man could master his environment, could understand it through his God-given intelligence. All these things will change as we move through the scientific revolution and the Enlightenment to follow. So, a few words about Copernicus, 1473 to 1543, Polish astronomer. He visualized the sun rather than the earth as being at the center of the universe. This, of course, is a dramatic shift in how we understand things, and a potentially dangerous argument to make because it decenters the importance of the earth, and in doing so, perhaps decenters the importance of man. So you can see that this could be a threat to the church. This heliocentric theory did not gain many adherents in the half century after Copernicus's death. I believe it's only taught at one or two universities. So it's not broadcast to the general public until Galileo comes along and makes Copernicus famous. After Copernicus, you have a Dutchman, Tycho Brahe. He's an important contributor to the scientific revolutions. What he did was make many observations of heavenly bodies and their movements. And he tracked these positions of the planets and stars, and he compiled just a mass of astronomical data that will be of great value to scientists that come after him. One of his students, Johannes Kepler, took this data and did make use of it. Kepler was, of course, a Copernican. He used Tycho Brahe's data to demonstrate beyond question the mathematical symmetry of the Copernican heliocentric system. Kepler discovered that Mars, the Earth, and the other planets orbit elliptically around the sun, not in a perfect circle, but in an elliptical orbit. And that the sun's not the center of this orbit, but only one focus of the ellipse. Kepler's work will provide Newton with ideas and data about planetary laws. This will lead, of course, to the theory of gravitation. The great star of the early modern scientific period, of course, is Galileo. He gains wide attention through his fame as a scientist and in his writings. He's cast even today in a sort of bigger-than-life mode like Michelangelo or Da Vinci. Most people have certainly heard of Galileo, even if they're not sure why he's important. In 1609, Galileo heard of an invention of a spyglass that might enlarge the celestial bodies. He constructed a spyglass of his own, called it a telescope. This magnified distant objects up to 30 times. In 1610, he announced this in his Starry Messenger of all the exciting new things that he'd been able to observe in the heavens through this telescope. He reported that the moon had a surface very much like the Earth's, that it was irregular, and you could see the pock marks from asteroids and comets that collided with it. The old notion is that as you move from the Earth into the heavens, that things became more and more perfect. Galileo's sightings tend to disprove this, that maybe the universe is a little more complicated than we realized. Galileo discovered the 4 moons that orbit Jupiter. This is evidence against the uniqueness of the Earth and its one moon. Perhaps moons are common, orbiting planets through the solar system. Of course, Galileo proved the theory of acceleration and the rate of fall of descending bodies. He proved that bodies made of the same material fall at the same rate, regardless of their size. So it's not surprising that Galileo's ongoing experiments tended to repudiate the old way of knowing things, Aristotle, Ptolemy, Christianity. This will in time get him in trouble with the church. This old way of knowing things, although of course Aristotle and Ptolemy are regarded as pagan, but they had been incorporated into the Christian cosmology over the centuries and accepted. Galileo and some of these new scientists, however, are going to propose notions that are not supported by Scripture. Galileo himself argued that Scripture and science are 2 different ways of knowing the world. And it's not the same sport. They're not competing. They're approaching the world from completely different perspectives and should be treated as separate truths. Of course, Galileo will get in trouble. One of the reasons is he takes some perverse delight in mocking or ridiculing people whose scientific opinions he regards as backward and stupid. This is going to get him in trouble, and we'll talk about that in our next session. Thank you.